In this video, I'm gonna explain a little bit about radicals and roots of numbers. And of course, I'm not talking about carrots or vegetables. We're talking about math. This is how radicals look like. Radicals have roots coming up. But first, a little terminology. This big red number is called the radicand. Radicand, a number to have its root calculated for. This purple thing, ziggy line, is just the root symbol. And then this number here, it happens to be a number 6, is an index number. But that's not very meaningful right away. So I'm going to explain it a little better here, and I'm going to give you examples how these read and what the heck these actually are. So that index number indicates the number of factors to be calculated of the radicand. I'll explain it coming up. Let's take a look at some of these radicals, how they read. Say, how about if I print it here? How about that? This one reads second root of 16 or square root of 16. Usually this number 2 is not printed by international agreement among pretty much all the countries, and it is usually omitted, but it's an invisible 2 that's there. So this reads as square root of 16. This one would read cube root of, 8. Cube root of 8. And the last one, fourth root of, 81. Okay, I'm going to show you through these examples what these radicals and roots are and how these index numbers and radicands and everything works. What I meant by these number of factors, okay, forget that sentence. The big idea with these roots is division. Okay, I'm going to write it here. We're going to be dividing everything in a special way. Roots of numbers means division. It's a special kind of division. It's just as plain division as division can be plain, but it's a special kind of division. This is what we mean. And this is where the factors come in. Say the factors of 16, I'm going to write it kind of small here. The factors of 16 are, whether it's in a T table or whatever you like, 1 by 16, 1 by 16 is 16, or 16 by 1, whatever. 16 also equals 2 by 8, that's also 16. And 16 is also 4 by 4. These are the factors of 16, the whole number factors. 3 is not a factor because 3 times something, that's going to be a decimal. And throughout this whole video, there's not going to be decimal numbers or fractions and negative numbers or any of that kind of freaky stuff. Of course, this pattern with radicals and roots can be extended into negative numbers, fractions and decimals. Don't worry about it. Just to get the big idea, we'll work with nice and easy whole numbers. So, when I said these radicals have to do with division, this is what it is. 16 needs to be divided by a number. So when it's divided, this divisor is the same number as the quotient. And this is why we made this factor 3, that in the case of 16, there's one situation there. 16 is 4 by 4, so the square root of 16, is 4, meaning that 16 can be divided by 4 to get 4. This number 2, invisible, this number 2, it means that you have 2 factors of 16. 16 breaks up into 2 equal, identical factors. This one is in terms of a division, or in a context of division. This is a this is a divisor, and this is quotient. Okay, so 16, so this one is a special division, that 16 is divided, so the divisor and the quotient are the same numbers. Okay, so that's what this means, and you read it as the square root of 16 is 4. Here's another one just to make sure you get the idea. How about the square root of 100? I'm not going to write number 2 there because, like I said, by international standards, it's just not written. And you also find the same on your calculator, say right around there. There's your square root button, there's your cube root button, and you can make fourths, fifths, any decimal or fractional roots of any kind of freaky numbers you can come up with. Second function on this one. The square root of 100 needs to be determined. So what you do is you take the factors of 100. 100 equals 1 times 100. 100 is also equals 2 times 50. Those are still two different numbers. 100 is 3 times, no, that doesn't work. How about 4 by 25? 100 is also 5 by, let me think, 5 by 20? How about that? 6 doesn't work. 7 doesn't work. 8 works. 100. No, doesn't work. 8 doesn't work. I'm just going to go 10 by 10. How about that? So 100 has, these are the factors of 100, but by determining the root of a 100, this is what we mean. 100 needs to be divided so that the divisor and the quotient are the same numbers. So there's only one combination for that. When you do that, 100 divided by 10 is 10. The square root of 100 equals 10. Okay? How about this one? The cube root of 8. How does this factoring work with the cube root of 8? Very straightforward. Works much the same way. 8 needs to have 3 factors instead of 2 factors. Now with the index number being 3, I want 3 factors here side by side that equal 8. Super simple. 1 by 1 by 8 is 8. What else is a factor of 8? We can do 1 by 2 by 4. This 8 is broken up into 2 by 4. 1 by 2 by 4, that's also 8. But we want 3 identical numbers. 8 is also equal. This 4 can be broken up into 2 by 2. So I'm going to write 1 there and 1 there. This 4 is 2 by 2. And that 2 just stays there. So 8 is 2 by 2 by 2. Okay. In this case, all factors are the same number. So 8 has to be divided in a special manner so that the first divisor and the second divisor are the same numbers as the quotient. That's what the meaning of the cube root of 8 is. And the cube root of 8 is 2. That's the answer to it. Alright. Now, one last example, just to make sure we're on the same page with this one. It's easy to do whole number. Easy? Yeah, it's relatively straightforward to do or come up with roots of whole number radicands, some, but some others, like cube root of 7, that's going to be a flipping decimal number. So most roots are calculated on a calculator. I also have a video. You can also do this root computation by hand. It takes quite some time and some practice to be good at. So if you want to enter the cube root of 7, just for argument's sake, this is how you do it. You have to enter on this calculator, you have to enter 3 for third root, second function, and that button there for the second function, because the 3, the x is going to be that index number, it's going up there. It looks like a multiplication x, but that's not what the calculator means. And just enter 7. Cube root of 7, there, 1.9, plus decimal change. Okay, so that's how you can enter these in the calculator. Now, but I want to do this last one quickly. The fourth root of 81 means that 81 needs to be factored out into 4 numbers. Okay, 1 by 1 by 1 by 81. I need 4 factors here. 81, let's say 81 also equals that. 81 can be, actually, instead of 81, can I do 16? Now let me just change my mind here and do 16, because it's a lot, it's easier, it's fewer numbers. Okay, I'm going to change my story halfway through to 16. Alright, that 16 is going to be 1 by 1 by, that 16 breaks up but into 2 by 8, so you can see the changes, and it's not too many lines to read and doesn't take forever to watch. That 8 again breaks up into 2 and 4. 1 by, and I'm going to write 2 here and 4 there. That 2 stays there. And so 81 is 1 by 2 by 2. 16, 16, 16. Alright, no more changes. 16 everywhere. 16 is 1 by 2 by 2 by 4. And that 4, of course, breaks up again into 2 by 4, 2, not 2 by 4, 2 by 2. So, and those 2's just drop down there, there. So 16 is 2 by 2 by 2 by 2. This is what we mean by fourth root of 16. And of course the answer is 2. 16 is divided by 2 by 2 by 2 again to get 2. That's what the meaning of fourth root is. In trades, most often, trades, technology and engineering, second and third roots are used overwhelmingly. That's why it's on your scientific calculator. But sometimes fourth, fifth roots are also used very rarely, as most things are either two-dimensional or three-dimensional, and a fourth dimension really cannot be modeled, or any other index numbers, because we're running out of existing dimensions as is. So that would be the lay of the land, and that's the big idea with roots and radicals, and that's how it works with division.